All right, good morning, period A1. This is Algebra 2 CP. Happy Friday, May 8th. I got a quick little do now for you right up here on some adding and subtracting fractions. If you noticed, last class we started off with multiplying and dividing fractions. That was a great review of the fact that if you have to divide by a fraction, you need to multiply by the reciprocal. And also, if you multiply fractions, you really just multiply the numerators and multiply the denominators. If any of you have any questions from the practice problems that I posted on Google Classroom, I did provide the answer key, so hopefully you consulted the answer key. But if you still have questions, even after looking at the answer key, and you really want me to go through more of that, then please stop by my office hours today at 1:30. If that doesn't work for you, then just send me a message and we'll try to schedule some other time that I can talk to you. Like I said, I'm pretty flexible, so please make sure you can just reach out if you need me, and I'll be sure to help you in any way that I can. Couple other things while hopefully you're working on these three problems. Yes, as I'm talking about these little reminders, make sure you fill out the attendance form on Google Classroom, so make sure that gets done. Make sure that your microphones are muted and your webcams are disabled, which seems to be the case across the board. And just one final note that I want to add. Every week so far, for 2 weeks now, going into the third week here, we have been having a progress assessment assigned the last period of the week and due on Sunday night. This week is going to be the exception. I don't believe that we've yet learned enough material for a progress assessment, so there will not be a PA this week. That's probably good news for everybody. It's like, woo, no PA. I will, of course, give you some practice problems. I'll give you some solutions along with those practice problems. We will be having a PA next week, but this week you do get a little bit of a week off from a progress assessment, just because I don't think there's much to assess, if that makes sense to you. Like, this stuff that I'm really presenting to you, the multiplying, dividing, the adding, subtracting, is really background knowledge for when we now move into solving equations. Once we get to solving equations, that's when we're really going to see those progress assessments and really going to work on those fundamental skills. But it's important that you understand this stuff to bridge to that stuff. So that's why there's not going to be a PA on this stuff, but there will certainly be at least, I think, two. I can imagine two when we get to equations. The way I kind of see it shaping up in my mind is 2 progress assessments on solving equations, and then an additional progress assessment on word problems. That will make 5 grades for the 4th quarter. If we have time for more, then we can do more, and if we don't have time for more, then so be it. But I at least want to get 5 because I think that's at least a good sampling of grades for you, such that it's not like 1 grade is counting for this huge percentage of your 4th quarter score. I think getting at least 5 was my goal. So if we can get at least 5, then I'm happy. If we can get more than 5, then that's even better, because even though you might be like, how is that better? That's just more work. Fair, but it's more grades to average out to be a more accurate representation of your performance in the 4th quarter. So just wanted to give you an update as to where we stand right now. But no progress assessment this week. You will get one next week, however. All right, so that all being said, let's now talk about how to simplify rational expressions involving addition and subtraction. Starting with this first one, which maybe you can figure that out in a snap. 2/7 plus 1/7. What is that equal to? Well, if you have 2 out of 7 things plus 1 out of 7 things, then now how many things do you have out of 7? This would be equal to just very simply 3/7. Okay? Because the denominators are the same, meaning you're measuring out of the same quantity, you could just say, well, I have 2 of these things, and now I have an additional 1 of these things, so overall I have 3 of those things. 2/7 plus 1/7 is 3/7. Does that make sense? Notice that it would not be 3 out of 14. You wouldn't do 7 plus 7 to get 14. You just do 2 plus 1 on the numerator. Because if you have 2 out of 7 things, and then you add an additional 1 out of 7 things, there's 7 things total, you have 2, then you have 1 more, you have 3 out of the 7. There doesn't suddenly become 14 things. It's not like the number of objects available just increases randomly and magically, right? There are 7 things total, so there remains to be 7 things total. I know that's something you may have already learned. You may already know that, but I just want to make sure I emphasize that because it will be important going forward. Problem number 2, though, is a little different. Problem number 2 is when we do not have a common denominator. So it's almost as if you had something measured in inches and something measured in miles, and you were asked to combine them into one unit. Well, you can't really do that because these are out of different scales. This one's out of thirds and this one's out of sevenths. Those don't fit together nicely. So what we need to do in order to be able to combine these fractions, we need to find what's called a least common denominator, which is commonly abbreviated as LCD, like the TV. LCD, least common denominator. So what that means is, what's the lowest possible thing that both 3 and 7 are factors of, they can fit into, right? We're talking about multiplicative factors, meaning don't say 10 because 3 plus 7 is 10. It means if you look at the multiples of 3, you have 3, 6, 9, 12, etc. You look at the multiples of 7, 7, 14, 21, 28. What's the smallest one of those that both 3 and 7 share? And the smallest number that 3 and 7 both fit into is 21. Does that make sense? Whenever we're in class, I always compare this to the kid's toy. I don't know if you played with it when you were younger, but it's that toy that's like this cube like this, and on the outside of the cube it has all the little shapes that you have to fit the round peg into the round hole, and the square peg into the square hole, and the star-shaped one into the star-shaped hole. The least common denominator is like what can accommodate all of those little pieces. Here's your round peg, here's your square peg. I need something that can fit all of those things together, and that's what your least common denominator is. So what I would like to do is I would like to make everything to be out of that least common denominator, right? That's the goal. I'd like this to now be represented out of 21. But the question is, how do I get from here to here, from 3 to 21? What do I have to multiply by? Well, I have to multiply by 7. 3 times 7 makes 21. So I can't just change the denominator, though. I have to also change the numerator. That means if 3 times 7 is 21, I have to do 2 times 7 to convert this to be 14 out of 21. Okay? Over here, I have 7 times what makes 21? That's 7 times 3. So I need to do the same thing in the numerator. 1 times 3 is 3. And so that's how we convert those fractions to be out of 21. You now have the situation we saw over here. 14 plus 3 is 17 out of 21. Makes sense? Last but not least, we have something like this. Something like this, it's really the same problem as number 2. It's just now we have 3 terms to consider. What's the least common denominator between 2, 8, and 6? If you think about it for a while, what's the smallest number that all of those fit into? The smallest number is 24. So if I want to convert everything to be out of 24, what do I need to multiply 2 by in order to get to 24? That's 12, so I need to do the same to the numerator, making this 12 out of 24. What do I need to multiply 8 by in order to get to 24? That's 3. I need to do the same to the numerator. What do I need to multiply 6 by in order to get to 24? That's 6 times 4. I need to do the same to the numerator. And now that all your denominators are the same, you could just go ahead and combine those numerators together, and you could say that this is 12 plus 9 is 21, minus 4 is 17 out of 24. And that would be your fraction. Does anyone have any questions about that? I know it's a little callback to adding and subtracting fractions. We're about to throw in some x's and some factoring in there, just like we did the other day. So does anybody have any questions before we do that? Questions going once? Questions going twice? Seems like we're A-okay. So, that being said, let's take a look at how the least common denominator works when we're dealing with x's and variables and stuff like that. It's a very, very similar concept. Okay. I also apologize if you're hearing any noises in the background. There's some landscapers outside working on the house right now, so it's a little loud, but we can get through it, no problem. So I don't know if that's picking up on the mic, but I can definitely hear it. It's pretty loud. So consider this example. I have 4 over 2x plus 3 over 6x squared minus 1/3. Okay? And I want to try to simplify that expression as much as possible. Well, obviously, all of these factors are completely different. We have a denominator of 2x, all the denominators rather. We have a denominator of 2x, a denominator of 6x squared, a denominator of 3. There's no way we can combine those right now. What we need to do is we need to find a least common denominator. We need to find a goal to aim towards. Well, when we have something like this, where all of these are just multiplicative factors, in other words, you have 2 times x, 6 times x squared, and just a 3. There's no adding and subtracting going on in the denominator, just monomials, monomial, monomial. What I always recommend is finding the least common denominator of the constants, meaning not the variables, and then find the least common denominator of the variables. So I have a factor of 2, I have a factor of 6, I have a factor of 3. What's the least common denominator of 2, 6, and 3? That's 6. Again, that's the thing that all those pieces can fit into. 2 times 3 is 6, 6 times 1 is 6, and 3 times 2 is 6, right? They all piece together into that. Now let's look at the variables. Here I have x, here I have x squared, and here I have no x's. So what do I need at minimum to accommodate everything, right? I need an x squared to accommodate everything. If I just have x, this guy would be happy because it would be like, ooh, I can fit into 6x squared, right? Just multiply by 3, and I get from 2x to 6x squared. But this guy, if I don't put this x squared, I would be like, wait a minute, I'm 6x squared, and you're only 6x. I can't fit. You're not accommodating me. So you need to make sure you have an expression that accommodates everything. In other words, I should be able to take this, multiply by something, and get this. And the same thing with this, and the same thing with this. Notice if I just had 6x and not 6x squared, how could I multiply this by anything to get this? You wouldn't be able to. It can't fit. Does that make sense? Okay. So now, just like before, that serves as our new goal. I'd like to get everything to be out of 6x squared. And so we just ask ourselves, well, what do we need to multiply by? In order to go from 2x to our least common denominator of 6x squared, what do I need to multiply that by? Well, it looks like I need to do 2 times 3 to get 6, and x times x to get x squared. So I need to multiply the top and the bottom by 3x, right? In the top, I'm going to do 4 times 3x, which is going to be 12x. I just wanted to make sure I wrote it out so that you see, yes, I need to multiply this and this by 3x. Okay? What do I need to multiply this and this by to get from 6x squared to 6x squared? Well, we really don't have to multiply by anything. You just multiply by 1. Right? It is what it is. We don't have to really adjust that one. And then this one, to get from 3 to 6x squared, what do I have to multiply that by and multiply that by? It looks like I need to multiply by 2x squared, because 3 times 2x squared would be 6x squared. So I'm going to do the same in the numerator. I'm going to take the 1 that's already there and multiply by 2x squared. We can now simplify that down to be 12x over 6x squared plus 3 over 6x squared minus 2x squared over 6x squared. And now we'll just combine those together the best we can. They all have the same denominator, so we can write that all over 6x squared. And here we're going to rearrange the terms of the numerator. We got negative 2x squared plus 12x plus 3. If you notice, we just combined all those terms on the numerator, and then I just wrote them in a familiar order. Okay? Sometimes it's possible to factor that and go further, but I just really wanted to demonstrate to you how these terms would all combine together. I'm not super focused on, going all the way with the simplifying right now. Does that make sense to everybody? Does anybody have a question on that? We're going to take a look at a couple more. Okay, how about if I have something like this? How can I simplify something like this? We got 7 over x plus 1 plus 3 over 2. Okay, just something like that, nice and simple. Now, something I really want to emphasize with this problem is, again, we need to find a least common denominator, because these denominators are different. The factor of x plus 1, however, is really just one singular factor. When you have addition like that, x plus 1, that is a factor of x plus 1. And that's something that's very important to get used to. It's not a factor of x and a factor of 1. That would be if we had 1x, 1 times x. That would be a factor of x and a factor of 1. This is a factor of x plus 1. It's just one singular piece, one singular peg that has to go into that cube. So my least common denominator, well, I need a factor of 2 to make this guy happy, and I need a factor of x plus 1 to make that guy happy. So your least common denominator is 2 times x plus 1. You now want to get all of your fractions to look like that least common denominator. So that's your goal, right? Your goal is you'd like the denominators to be the same. So what do I need to multiply this by in order to get this? Multiply it by 2. So we do the same to the top, giving us 14, 7 times 2. What do I need to multiply this by in order to get this? Well, we're missing this piece of x plus 1. So that's exactly what we need to multiply by. We have to do the same in the top. We get 3 times x plus 1. Now they have the same denominator. We can go ahead and stick them together. I have my 14 plus. We would do a little distributing here with the 3. You'd get 3x plus 3. And then you could just simplify that down even more to say this is 3x plus 17. That's 14 plus 3 all over 2 times x plus 1. Okay. I know that doesn't clean up super nice, but that's the idea of how you stick these things together. That's really the takeaway I want to get from this lesson. Does anyone have a question about that? Again, a really important point is the fact that this is a singular factor of x plus 1. It's not a factor of x and a factor of 1. It's a factor of x plus 1. It's one piece. All right, let's take a look at a couple more. Maybe let's do a little bit of factoring. Let's introduce a little bit of factoring. How about something like this? Ready? Good example here. 3 divided by x minus 2 minus 4 divided by x plus 4 plus 1 divided by x squared plus 2x minus 8. And we want to try to simplify that together into one term. Well, what you may notice right off the bat is x squared plus 2x minus 8 looks super factorable to me. If you look at that, I would think to myself, oh, that's a factorable thing. That is a thing that I could take, and I can factor that trinomial. That's exactly what I would do. So let's start by leaving everything the same, and we'll just factor that piece over there. We got 3 over x minus 2, 4 over x plus 4, and then I got my 1 over, how do we factor that down? We need x and x to make x squared. I need 1 negative, 1 positive, and I need, looks like plus 4 minus 2, conveniently enough, matching with our plus 4 and minus 2 over there. Now the question becomes, I would like to combine all those things together. I would love to stick them together, but how the heck can I do that? I can't right now because the denominators are all different, but I can find a least common denominator. This denominator has a factor of x minus 2. This denominator has a factor of x plus 4. And this denominator has a factor of x plus 4 along with a factor of x minus 2. So what needs to be in my denominator to make everything happy? Well, I need a factor of x minus 2. That makes this piece happy and this piece happy. And I need a factor of x plus 4. That satisfies this, and that satisfies this. Does everybody see that? So your least common denominator would be x minus 2 times x plus 4. Now, you want everything to look like that. So I want now this to look like that. I want this to look like that. And I want my last term to look like that. Right? I want everything to be of that common denominator, so then I could squish it all together. Okay? What do I need to multiply this by in order to get this, though? The thing that's missing is the x plus 4. So that's exactly what I need to multiply both the top and bottom of this guy by. I need to do 3 times the x plus 4. That was missing. What do I need to multiply this by in order to get this? Well, the x minus 2 is what's missing here. So I need to do 4 times x minus 2. What do I need to multiply this by in order to get this? Well, nothing at all because it's already the same. So we can just leave that as a plus 1. Okay, really we multiply it by 1, but multiplying by 1 doesn't change anything. Now that they're all the same denominator, we can go ahead and squish them all together. Notice I'm going to do a little bit of distributing first. I'm going to do 3 times x and 3 times 4. That's 3x plus 12. Over here, very, very tricky and a good thing to point out in this problem. Notice that we have negative 4 times this times this. A lot of students will forget and neglect that negative sign out in front there. Please do not make that mistake. It's a very easy one to do because if you just look at this, you'd be like, oh, 4 times x, 4 times negative 2. But remember that we're subtracting this term. This is a negative 4 times x, negative 4 times negative 2. Very important thing because that's easy to overlook. If you wanted to at the very start of the problem, I don't know if I really recommend this, but you certainly could. If you notice this minus here, you could like change it to that if you really wanted to just make it so that, oh, the negative's already here and we just make that a plus. That's fine. I think that might be a little excessive, but if it's comfortable for you, hey, go for it. I just thought of it off the top of my head. So here we got minus 4x plus 8, very important. And then we have one additional plus 1. And now I would just go ahead and combine all those terms as best I can. 3x minus 4x is negative 1x. 12 plus 8 is 20, plus 1 is 21. All over this x minus 2 times x plus 4. And that's how we could simplify that. Does anybody have any questions, comments, concerns about that at all? Pretty cool. The big takeaway, again, being the least common denominator. We understand how we're constructing that least common denominator. That's a very, very important idea because that's exactly what we're going to have to do when we solve equations. When we throw an equal sign into here, we're just going to have to find the least common denominator of everything and then, try to work with it as best we can. Now, let's take a look at one more example. I think we have time for one more, and then we'll probably be done for the day. Probably take about 4 minutes and then maybe end about a minute early. So, let's take a look at something like this. How about if I had x over x plus 3 minus 18 over x squared minus 9. And we want to try to find a least common denominator, simplify those things, and stick them together. Really cool problem here because there's a lot of simplifying you can do with this one. So, first things first, again, your Algebra 2 eyes should be drawn right to that problem. I know at least for me, when I see something like that, I'm like, bam, I zero right in on it. I'm like, x squared minus 9, that is prime time difference of 2 squares. And so that's exactly what I'm going to do. I'm going to take the difference of 2 squares on that and rewrite this as x over x plus 3 minus 18 over x plus 3 times x minus 3. Right? Nice difference of 2 squares factoring. Been there, done that. So we should be comfortable breaking that down. Now that I have this and I see everything in my factored form, it's very easy for me to find that least common denominator. Note that it would be, by the way, I should have mentioned this in the previous example. Notice how difficult it would have been to find the least common denominator without factoring, right? What would your least common denominator have been? This, times this, and then you would have been multiplying excessively? No thanks. Factor first, it makes it much easier to identify your least common denominator. Same thing here. We factored first, much easier to identify that our least common denominator, let's see, we need a factor of x plus 3. That makes this happy. That makes this happy. We also need a factor of x minus 3 to make that happy. Okay, now everything is happy. Now we can go ahead and try to convert everything to be that least common denominator. We have x plus 3. We have x minus 3 here. Same thing over here. We have x plus 3 and x minus 3. That's what I'd like to get to. That's my goal. That's what I'm aiming for. So what do I need to multiply this by in order to get to this? Well, the missing piece is x minus 3. And so that's exactly what I need to do on the top. Right? What's missing to get from here to here? Again, nothing at all. We can just leave that one alone. Continuing the problem up here, we can distribute these and combine them together into a single fraction. Notice I have x plus 3 times x minus 3. Distributing that, we're going to get x squared. That's x times x. See that from down there. X times negative 3 minus 3x minus 18. Everybody see how we're transitioning? Hopefully it's not unclear. Hopefully it makes sense. Hopefully we're all paying attention and following along. Yes? Great. Oh, man. I take your silence as, yes, Mr. Giorgio, this is fantastic, and I feel, enlightened. And speaking of enlightenment, we can attain even further enlightenment by looking here and noticing, ooh, wait a minute. X squared minus 3x minus 18, that looks very factorable to me. And in fact, we can factor that down to, You thought you saw the top of the mountain before. Oh no. Oh no, here comes the top of the mountain now. X minus 6 times x plus 3 all over x plus 3 times x minus 3. And then, ooh, another exciting moment. X plus 3 over x plus 3 goes away, and I can simplify this down to x minus 6 over x minus 3. Can't touch it any further than that. So that's pretty good, though. That's pretty good. Taking something like this and squishing it down to one term. Really great stuff. Keep in mind, again, we couldn't just cross out that and make it negative 6 over negative 3 and make it positive 2. That's very, very bad algebra. It's a tempting mistake to make, but please, please, please don't do that. Just to reiterate the point from last class, the reason you can't do that, the reason I can't just cross out x and x, or just cross out negative 6 and negative 3 and write a 2 here, like if you're reducing everything by 3, write a 1 there, is because that's not how regular old numbers work. If I had something like 5 plus 3 over 5, right, what's that going to be? We know just from like second grade, that's 5 plus 3, which is 8 divided by 5, right? Which is some decimal. It's what, 1.6. You couldn't be, you wouldn't say, oh, cross out the 5s and that's 3, right? That doesn't make sense. 5 plus 3 divided by 5 is not 3. So anyway, that's why we can't do that. Very, very bad stuff. Okay. All right. Any other questions, comments, concerns about finding a least common denominator, converting everything to a least common denominator, and then combining like terms? That was the takeaway for today. Going once. Questions? Going twice. We got 2 minutes. Questions? Sold. Again, I want to emphasize the fact that there is not going to be a progress assessment this week. You can enjoy your weekend off. Enjoy Mother's Day. Happy Mother's Day to all the moms out there. One thing I do want to mention is, again, remember that these lessons are being uploaded and recorded and all that stuff. So please watch them back if you are confused or need a refresher or anything like that. I am going to post practice problems on Classroom today. I'll probably get them up during lunch. So you can take a look at those. I definitely recommend trying those, looking at the answer key, which will be provided, and doing that. It will not be graded, but again, it's only for your benefit. We are now going to use the skills that we learned of multiplying and dividing rational expressions, as well as adding and subtracting rational expressions, to now transition into solving equations next week. There will definitely be a progress assessment next week, the week after, and probably even the week after that. But it should take us right into the end of the year, on a nice little schedule there. So if you have any other questions, please feel free to reach out and let me know. Other than that, thank you for your attention and focus today. I will see you on, when do I see you again? Tuesday. So have a great weekend. Enjoy. Bye, everyone. Bye. Have a good day.